Continuing our discussion of Linux stack buffer overflows, in previous videos, we determined that it's rather difficult to exploit a stack buffer overflow in a standard Linux application that has the stack protector enabled, which they all will by default. So, what I've done is I've added to my Here I have my address. I could print it out a different way as one nice big number, but I can look and I can find my function, and I can find my function pointer that points to that function. I can look at function. I can look at the scope of it, and you'll see that I have variables that have been set up. And I can use some of those variables to figure out where I'm going to find a potential vulnerability. I can also disassemble this function, which will tell me where in memory or in my virtual memory space I can find that function. So there are a couple of different things that I can do in order to track that down a little better. So I guess the moral to this video is that it's hard in Linux to take a stack buffer overflow and turn it into anything useful. But there are a couple of cases where you can do that. If you have a function pointer that's being passed in as an argument that can be somehow overwritten, if you just plain get lucky and it happens higher in memory than some other parameter based on how things get rearranged, you might be able to overwrite that. Also, if you are encountering C++ programs, you should be aware that C++ classes implicitly have function pointers that point to the class and its methods that might be out there and might be exploitable as well. That's all for this video and our introduction to Linux stack buffer overflows and attempting to get exploitable vulnerabilities from them.